Okay, so today we're going over 2.1, and we're getting into something called logs or logarithms. That's the actual name. Log is short for logarithm. So today, by the end of today, you should be able to find exact and estimated values of logs, make conjectures about a logarithm and their properties. What is a logarithm? How can we tell if one log expression is bigger than another? And how can we estimate log values? And how do logs relate to exponents? So all of these things here, you'll be able to do. Right now, it seems like, what? Like, no. But this is kind of, if you think about this, this is kind of like our agenda for our learning. So keep these questions in mind. Like if you focus in on these as we go through these slides, you'll notice that your brain is a little bit more in tune to where I want it to go, right? Okay, so the next slide talks of, it's almost like an intro or a retro, whatever. So we began thinking about logarithms as inverse functions for exponentials when we, in the last couple lessons. Logarithm functions are interesting and useful on their own. In the next few tasks, we will be working with understanding logarithm expressions, functions, and operations on equations. So we showed the inverse relationship before. Remember, we did this like 3, and I plug it in, I get 2 to the third. The way you undo that is you're thinking like, okay, well, what's the exponent, right? What's that exponent when 2 is the base to get 8, and it's 3, right? So the next thing is we could summarize this relationship by saying 2 to the third equals 8. So log base 2 of 8 is 3. So make sure you're saying this properly. I won't ever ask you how to do anything audibly in terms of tests, but you also want to be able to speak intelligibly about this stuff. So say log base 2 of 8 is 3. In reality, all I'm saying is 2 to the what gives me 8. This is the way I see it, but the way my brain thinks about it is this. Okay. And pretty soon, just like a new language, you'll be able to look at this and be like, oh, I know what they're asking, right? But right now you're still learning this land called logs. Okay. So just, there's a language to it. There's laws to it. Just keep that in mind. So logs can be defined at for any base with an exponent with an exponential function. Base 10 is popular. So using base 10, you can rewrite statements like these. So 10 to the first equals 10 because log base 10 of 10 is 1, right? We know this is true. So similarly, this is true. So if you think about this in languages, this is how we would say it in exponential land. And this is how we'd say it in log land, right? It's just 2 different languages. We're really saying the same thing. Like, I have a question, you would say in English, and in Spanish, you would say, tengo una pregunta, right? And same thing goes here. 10 squared equals 100. So therefore, log base 10 of 100 is 2. So get your eyes familiar with this. Get your brain to think this, even though you see this, right? So the notation may seem different, but you can see the inverse pattern, which where the inputs and outputs switch. Inverse, right? We talked about this before. The input here is the output here. The output here is the input here, right? So the next few problems will give you an opportunity to practice thinking about this pattern and possibly make a few conjectures about other patterns related to logarithms. Okay. So here we go. So this is problem 5. So what they want you to do is they just want you to put this somewhere on the number line. So even though it's here, I'm going to be doing it here because it's easier for me to annotate on my iPad, even though sometimes it doesn't catch up, but that's okay. So here goes. This first one, let's make it a tad bit bigger. So it says, place the following expressions on the number line. Explain why you think that. So pick one of these and tell me which one that you know is true. Pick one of these and tell me which one you know where to put it. Pick one of these. And you could just say A so that you don't like have to write all that out. Awesome. Where do you think A goes? Where do you think A goes? Let's just start with A. Ooh, a bunch of people just said A is 1. Okay. So they think that A goes right here. And the reason why that makes sense, right? The reason why that makes sense is because even though I see this, again, I'm going to tell you what I think about this. So in my brain, right? In my little brain here, I'm thinking of 3 to the what gives me 3. 3 to the what gives me 3, right? 3 to the what gives me 3. And then you're like, oh, that's just a 1. So therefore, this thing is just equal to 1, Ms. Johnson. Yeah, this is just equal to 1. That's why we put it there. Very good. So we have a bunch of really good answers, really strong answers. A's right here, perfect. And then practice. Can you guys practice chatting publicly? It's okay to chat publicly. It's okay to be wrong publicly. It's perfect. Okay, so if that's 1, then what would B be? If that's 1, what would B be? Right? Yeah, B would be 2, exactly. Why would B be 2? Okay, so then again, with my little cloud, right? So log base 3 of 9 means 3 to the what gives me 9. 3 to the what gives me 9. That's what this thing is saying. 3 to the what gives me 9. And you all said 2. Yes, it's because 9 could be rewritten as 3 squared. Very good. Now this thing is slow. It's not slow today. Hold on, guys. All right. So exactly. So I'm going to put B right there at 2 because you guys said 2. And because of 3 squared gives me 9. If you keep and continue thinking about this, we had reviewed, now you understand why they kept asking you about rewriting these fractions in terms of exponents. Now you understand why I was making you do that, right? So now in terms of log base 3 of 1/3, log base 3 of 1/3, what would that be? Log base 3 of 1/3. Now, last time we had reviewed, right? We're like, oh, what does that mean again? It's just, yeah, you're dividing. So if multiplying by 3s gets you bigger numbers, then dividing by 3s gets you smaller numbers. And in this case, a -1, right? So here I'm going to put a -1, and that's exactly right. That's what C is. Again, you want to get to the place where you see this and you know how to say it in exponentials, right? So for me, in terms of Spanish, for those of you who natively speak Spanish, meaning you've been speaking Spanish since you were a wee little one, right? You probably are so good at speaking English and Spanish that you probably think in Spanish, right? I'm not fluent in Spanish. So whenever I want to say something in Spanish, I think about what I want to say in English. And then I convert all that to Spanish, and then I speak that, and then I fix whatever I need to fix, right? So same thing goes here. Here's how to say it in log land. So I'm going to be thinking about how to say it in exponential land, right? And then I will translate what I need to. So very good, strong work. What about this one though? Log base 3 of 1. Log base 3 of 1. Log base 3 of 1. Yeah, it's 0. Now, why is it 0, Miss Johnson? If you remember that chart that we did a while ago, gosh, I don't know where that chart is. I'm just going to make a new one really quick. When we wrote a chart out, we said, 3 squared is 9 because it's 3 times 3, it's 9, right? And then if I went up, then I was just multiplying by 3. 3 cubed is 3 times 3 times 3 is 27, right? I really don't care about that 27, but I just want to make a point. If I go down, that's me dividing by 3. So that's 3 to the first. There's 1 3 there. If I divide by 3 again, that's 3 to the 0, which just means it's 3 divided by 3, which is just the number 1. Okay, so this is going to catch up to me one day. I promise. It's just not catching up right now. Okay, so there it goes. And that's why it's 3 to the 0 is 1. And if you keep going on this pattern, 3 to the negative first actually gives you a divided by 3. Okay, so again, take a look at this chart and if you continue this pattern going down, you'll get smaller and smaller values of that, which this is why that last one was 0. That's why that one is going to be 0. Very good. All right, continuing on. So this would be the letter D. And where would log base 3 of 1/9 go? Where would log base 3 of 1/9 go? Yeah. Okay, so you guys get this. So for those of you who are unsure of this, just make sure that you're comfortable with this idea. If you know what 3 is, because it's 3 to the what gives me 3, then you're comfortable with log base 3 of 3. This is where people get a little bit confused and want to put like, I don't know, they want to put fractions for fractions, and they want to put negatives for negatives, and that's not correct. Okay, so this last one is -2. So this is equal to -2. Very good. And then that completes that. So everybody, if you don't have this information on your slide, get it on your slide. If you have it on your slide, make sure it goes in your head. Okay, I see some awesome names in there that are participating for the very first time. Very good, very strong work. So same thing goes here. They just want you to continue giving a number line for this one. Your number line looks a little bit different, 0 to 5. I'm just going to get a little smaller so I can see both of those at the same time. So continuing on, is there any of them here that you're like, Ms. Johnson, I don't get it? So A, give me the answer for A. And then practice 2, for those of you who are getting a little bit like stuck, rewrite this so that you can think about it in terms of exponents, because then it'll help you out. Exactly. A bunch of people put 4 in the chat. Perfect. And it's because 3 to the 4th gives me 81. That's perfect. So that's where A goes. I think you should be okay with B. Go ahead and tell me where B goes. Yeah. B goes to 2, right? Because 10 squared is 100. Very good. You're just constantly thinking, what exponent am I using? What exponent am I using? Very good. Strong work. Are we getting stuck a little bit? What about log base 8 of 8? Log base 8 of 8. Log base 8 of 8. What about that one? Very strong. Yes. It's 1. You're very right. So I should write these answers. Sorry. So this is 4. This is 2. This is 1. So that goes right here. This seems like you guys are getting it, right? For those of you who are like, wait, I'm lost. What are they doing? Take a second here. Okay, rewrite this one using exponents. 5 to the what gives me 25. 5 to the what gives me 25. Yep. So 5 to the what gives me 5? 5 to the what gives me 5? Uh-oh, we got a little dissension here. It's not 5. It's not to the 5th, right? Because 5 to the 5th is some gigantic number. Let me prove it to you using my calculator. 5, and then this expression here means to the 5th is that number, right? I just want 5 times how many do I need to get to 25? Exactly, it's 2. Very good. And if you're messing up, good. I don't know, messing up, good. Ms. Johnson, but we already have a letter on B. That's fine. That's fine. Give me a second, guys. Okay, so some of you are thinking, oh no, Ms. Johnson, there's already a letter there. That's okay. It's really okay. It's okay if there's another letter. You can have multiple letters on the same thing. But Ms. Johnson, does that mean that log base 10 of 100 is the same as log base 5 of 25? Yes. Oh, I put the wrong letter. Dang. I've been making mistakes, y'all. Thank you for keeping me honest. D, not E. Very good, because log base 2 of 32 is not 2. Haha, thank you. Thank you for that correction. Log base 2 of 32 is not 2. I'm thinking in my head, 2 to the what gives me 32. Now, you should be saying this over and over again until you get to my level, right? Until I get to the Spanish fluency level that maybe some of you are at. I should continue to practice over and over again so I get super familiar with it. So continue to say 2 to the what gives me 32. 2 to the what gives me 32. Okay. Yeah, it is 5. And the reason why it's 5 is because 2 times 2 is 4. Times 2 times 2, that's 4. So 4 times 4 is 16 times 2 is 32, right? So yes, this equals to 5. So here is the answer that you would get. Here is the brain work that's happening in your brain in order to get that. Okay, and so yes, that's E, and E is 5. So I'm going to place him right here at E. Very good. So now that you're seeing these, you can almost like start to see how we're going to start comparing these numbers and saying, oh, this needs a bigger exponent than this guy does. Therefore, log base 2 of 32 is greater than log base 5 of 25, right? Because clearly to go from 2 to 32 is like multiple, you're multiplying 2 several times, right? Okay, so what do you guys notice here? What's a conjecture that you guys can write? So we're writing conjectures. What a conjecture is it's almost like your observation of, wait, what do I want to say? Is your observation of what is happening, and you don't know if it's true or not, but you're going to say, this is my kind of like, I don't like to use the word guess, but it's my best like effort at thinking about this. So anybody see any trends that they see here? Any conjectures that they want to raise about logs? Like the answer here is always going to be the exponent, right? That's a conjecture you guys can do, right? Other conjectures that you can possibly make. Let's see. For this number 2 right here, any conjectures that you guys can see? Not yet. Okay, you'll see some. Just keep looking for like trends. That's what you want to look for. So let's do these. Which ones are easy here? Which ones are annoying? Which one's easy for you here? Oh, I went too far. There it goes. What about that A? What is A equal to? Ooh, I like that. Someone wrote this. Sorry, I'm going to snip this one really quick. Let me grab this. Someone wrote this as a conjecture. This is a really good conjecture. I like it. Someone put this conjecture and they said multiple problems can have the same answer. You can't see it right now. Hold on. Multiple problems can have the same answer, exactly like we had this one, right? These two had the same answer, both B and D. Very good. Okay, so you all said that A is 1. A is 1. How did you know that? Did you calculate it? Did you think about it? How did you know that? Did you translate it into your head in terms of exponents? Very good. Yeah, same base and same exponent. Very strong work there. So that could be a conjecture here, right? If they have the same base and same exponent. I mean, this number, they don't call this the exponent, they call it the argument, if you want to call it something. So a conjecture that Alyssa is trying to make looks something like this, right? So log base B of B equals to what? Log base B of B equals to what? That's what she's kind of saying there. A and B are 1 because they have the same number. That's another fantastic conjecture. Let me click that really quick. And when he says the same number, you understand what they're saying? They mean the same base and the same argument. So that number right there, what you're taking the log of, it's called the argument, right? Very good. Okay, so this person says, Ms. Johnson, both of these are going to be 1 because both of them have the same base and argument. So log base B of B, they're saying, right? What about these two? Log base B of 1, log base B of 1, or log base 11 of 1. Very good. Someone in the chat said 0. So I'll put that right here at C. And what about the next one, log base 10 of 1? Oh, that's 0 too? What? So how would you generalize this one? How would you generalize this one? How would you generalize C and D? What would you say here? Yes, very good. So someone said both of them are going to be 0 because anything to the 0 is going to be 1. Exactly. So you can kind of hear this person's already got like the translation down in their head. They understand I'm looking at logs, but I'm thinking in exponentials, right? So if I was to write this in terms of logs, it would look something like this. Log base b of 1 is going to be 0. There are some stipulations here. I'm kind of generalizing what you guys are saying, so it's a little bit easier to read. But log base b of b, you guys all said, oh, this is going to be 1, kind of like what this person said, because the number, they have the same numbers right here, right? The base is the same as the argument. So here, this is like b to the 0 is going to be 1. There's a stipulation that I will tell you about, and I'll tell you about it in a little bit. But just know right now that these are really strong pieces of information that you've come up with. Okay, next one. So log base 2 of 1/4. Ugh. What do all of these have in common, guys? What do all of these have in common? Yeah, they're all gonna have a negative exponent. Boom. Very good. Why are these ones gonna have a negative exponent? Very good. Very good, both of you. Very good. Yeah, because they're all fractions, right? So someone said this in the chat. I'm going to copy it here. They're all going to have negative exponents because these are all fractions. Someone else said that. Very good. These are all going to have negative. And notice here, they give you a negative side. Isn't that nice of them? So here, go ahead and tell me what these are. What is A? And how are you thinking about it? Have you guys gotten into the translation? So you're thinking, in my head, I'm saying 2 to the what gives me 1/4. And so my answer here is, oh, I'm dividing by 2. How many times did I divide by 2 to get to 4th? Oh, I divided twice. So because I'm dividing, it's a -2. So there goes that answer. Right. What about B? What about B? How many times did you divide by 10? Very good. Yeah, I divided 3 times by 10. So that's going to be B. So that's -3. This is -2. Same thing goes, right? Do you guys all see the dividing by? I'm dividing by, I'm dividing by. I'm dividing by 5. How many times here? How many times am I dividing by 6 here? Kind of thing. Very good, very good. Hold on, guys. Let me pause this recording. For this one here, if you notice, we're just dividing by powers of that base, right? So yes, this is -3, very good. And down here, this is -1. So right on, right? The person who said all of these are going to have negative exponents. And someone else said the reason why they're going to have negative exponents is because these are all fractions. So don't fall into the trap that people say, oh, the answer is going to be a fraction because look, there's fractions right here. No, that's not correct. So go ahead and put the answers there. I'm going to put this as our conjecture here. They all have a negative exponents. And then I'm going to write on top of that, because the arguments, oh shoot, how do you spell argument? Okay, no E, sorry. We don't know how to spell sometimes. We're all fractions. So just a reminder of what an argument is so that you will remember. Log base B of, I don't know, X. So that is the argument. Okay, X is the argument. Good? Everybody okay with that? Boom. Okay. Okay, so as a mathematician, the thing you should be thinking of is what do all of these have that are the same one? You can write the observations. Your observations are the more powerful part. You doing the work is helping you write an observation. If you don't have an observation, that's okay. You can take mine. Or actually, this one's not mine. This one's one of your classmates. That's okay. Very good. Yeah, yeah. What do all of these have in common? No. So the 16 is actually called the argument. Yeah. Very good. These all have the same arguments. Very good. Yeah. It's okay if you're still learning the language. They all have the same argument. Very good. Okay, these all have the same argument. So because they all have the same argument, it's going to be interesting to compare these. Like, which one do you think is the biggest number here? Which number do you think is the biggest number? A, B, C, or D? Which one do you think? Yeah, they're all going to have positive exponents. That's awesome. Very good. Yeah, B is going to be the biggest number, right? B is going to be the biggest number. Ms. Johnson, why is B going to be the biggest number? Because to get from 2 all the way to 16, I'm going to have to multiply 2 by several numbers, right? So 2 times 2, I'm only at 4, times 2 is 8, times 2, oh, that's going to be 4. So this number here is going to be our biggest. Very good. So this is going to be B. Very good. Which number is going to be the smallest? Which number is going to be the smallest? Yeah, D is going to be the smallest. And for those of you who don't understand why, take the risk, right? Why would, now just pause really quick, okay? Don't get worried about you not knowing how to explain this perfectly. Just kind of look at this. Ms. Johnson, you said the biggest number was gonna be B, this guy here, and the smallest number is gonna be this guy here. Yeah. So in reality, you can't compare these 16s because they're all the same. So shoot, that must mean I have to compare the bases. Correct, right? The further away from these numbers are, I guess that's a good way to say it. To get from 2 to 16, you're gonna have to multiply 2 several times to get to that 16. Well, in reality, for 16, I was already at 16, so that's why it's the smallest. Yes, very good. Someone else said, Johnson, we know that log base B of B is 1. And that's what we said over here. And again, these are still conjectures. They're not like firmly planted. These aren't laws yet. They become laws when either one, you've proved it, or number 2, that you've studied this and you've looked at a bunch of different cases. Right now, these are still conjectures. So I like that you're bringing that up, though. That's strong work. Very good. Okay, so then what would log base 4 of 16 be then? What would log base 4 of 16 be? Very good. So that's A. And then log base 8 of 16. Dun, dun, dun. This one's going to be interesting. Log base 8 of 16, I'm going to write over here because we want to talk about that guy for sure. If you don't know why I want to talk about him, it's because 8 to the something gives me 16, right? There is a something that I can take 8 to, but it's not a whole number. Right? It's not a whole number. So this one is going to be pretty interesting. I definitely know that log base 8 of 16 is bigger than 1. You guys all with me that it's bigger than 1? Right? It has to be bigger than 1. But it's definitely smaller than 2. It's definitely smaller than 2. Why would I say that log base 8 of 16 is smaller than 2? Why would I say that? Why would I say that log base 8 of 16 is smaller than 2? Yes, yes. Okay, exactly. So someone said this in the chat. I got to write down. Boom. This is some high level knowledge, y'all. Copy, paste. Perfect. I know that log base 8 of 16 is smaller than 2 because 8 squared, right? That's the 2. 8 squared would be 64, which is much, and 16 is much smaller than that. So, right, it has to be smaller than 2. Very good. Strong work. Move this a little. No. Right here. Perfect. So then, Ms. Johnson, what would log base 8 of 16 be? Now, here, can I ask you this question? I know that it's smaller than 2, okay, because of this, what was shared, okay? Now, do you think that log base 8 of 16 is closer to the 1 side or it's closer to 2? Do you think it's closer to the 1 side or close? Yeah, it's closer to the 1 side. So for those of you who are like, Ms. Johnson, why is it closer to the 1 side? Right? I know it's closer to the 1 side because of the log base 8 of 8 business, right? Log base 8 of 8 business. So let me just write this down. Let me move this guy over here because I want to write something below it. I know that this is true because I know that this guy is log base 8 of 8. And I know this guy, oh, it's not going to move. Hold on, there it goes. So I know this guy is log base 8 of 8. And I know this guy is log base 8 of 64 per what my friend right here said, right? So that means if I was taking a look at my arguments, the 8 versus the 64, 16 is way closer to 8 than it is to 64. So I'm not exactly sure where it is. Actually, I know exactly where it is, but right now I'm just gonna pretend that I don't. I'm gonna move him closer to the 1 side than to the 2 side. So I'm just gonna put him here at C, and I'm gonna put a little star next to him so that you know to go look over here. Okay, so this, I'm just gonna put it closer to the 1. Is it exactly right? Right now, no, because you don't know exactly where it should fall between 1 and 2. Right now, you should be comfortable with, okay, I know it's bigger than 1. I know it's smaller than 2 because of this, right? And I know that it's closer to the 1 side because log base 8 of 8 and this, right? I know you're asking, but I'm not going to tell you right now. Sorry. So a conjecture for this one, what would a conjecture for this one be? Because you guys all noticed that they had the same arguments, right? What were you able to tell? It has to do with something about the same arguments. Yeah. So because we were able to like you know, have you ever heard that phrase comparing apples to oranges? That phrase comes from like the idea that you're not comparing things that are the same. So here, because we were able to hold the arguments the same, then we were able to compare the bases, right? So same arguments allow comparison of different bases. So these are just a lot like little notes to myself. I'm not actually writing a conjecture, but I wanted to remember that these all had the same arguments, and that's how I was able to order these, right? Okay. All right, let's move on. Hold on a second. Let me just check something this way. So we are on number 9. Okay, so let me do till number 6. That's good. Okay, so here, this one says log base 2 of 5. Oh no, log base 2 of 5. Okay, so this one, I want you to pause really quick. Based on what we just did right here, you should be a little bit more comfortable with this stuff here. Okay, so for sure, which one do we know goes where? Does anybody see one like, oh, Ms. Johnson, I know this one goes somewhere. Which one of these do we know the most about? Okay, D is 1. Oh, yeah. You guys should all remember why D is 1, right? D is 1. Everybody good? Okay. And then someone else said, oh, C is 0 because anything to the 0 is going to give you 1, right? Okay, so those ones for sure I can do. So right now, I want you to I'm going to pause the recording, and I want you to think about this one right here, and just do kind of like an argument like this between what 2 numbers, because 2 to the something gives me 5. I don't know what that something is, but I do know it lands between 2 integers, right? So I want to figure those out. So do A, B, and E similarly. Okay, do A, B, and E. Okay, so some of you are already telling me awesome about all the things that you wrote here. Okay, so here we got someone said for log base 2 of 5, Ms. Johnson, I know it's bigger than 2 and smaller than 3. Exactly, right? So can we just take a second and look at that really quick? So log base 2 of 5, they said, I know is bigger than 2, but smaller than 3, which kind of makes sense, right? So, oh, this is not catching up to me. There it goes. So log base, the reason why it's bigger than 2 is because 2 to the second gives me 4, which 4 is smaller than it. So that's why I'm going to write log base 2 of 2, which, oh, not 2, sorry, of 4, which is the same thing as 2. You're not going to catch up to me. Here we go. Okay, there it goes. And then log base, this is log base 2 of 4, and this one is going to be log base 2 of 8, right? And so if you think about where does 5 sit, is 5 closer to my 4? Is 5 closer to my 8? And you guys are like, oh, it's really close to there. So it's got to be closer to that 2. So that's why he is going to sit right next to that 2. So this is where A is, right? Okay. For this one, I'm not gonna put equals to whatever. If you notice, I didn't put equals to whatever here because I don't know the exact one yet. So same thing goes with this one. This is bigger than, for me, this one's bigger than 1, but it's smaller than 2. Bigger than 1, smaller than 2, and it's closer to the 1 for me. So this was my B. That's where I put my B. Okay, and this one right here, wow, 10, it's smaller than 5. So don't think negative, think fractional, right? So this is definitely bigger than 0, right? Because this is bigger than, this one's gonna go like this, sorry. This is gonna be bigger than log base 10 of 1, right? So it's bigger than 0, right? But it's smaller than log base 10 of 10. So it's smaller than, there it goes. It's smaller than 1, but bigger than 0. It's like smack in the middle, Miss Johnson. So what do you want me to put? So please don't say that it's half, okay? Because that's actually not accurate. So just put it somewhere. And technically, I'm going to put it closer to the 0 side because it's only 4 away from 1, right? And this is the letter E. Okay. Okay, last little one that I'm going to do is this one. Now over here, we did same argument, and here we're doing same base, right? So here, if you notice, there's going to be, like, this is a 3. That's clearly a 3 for me because I know logs, I know base 10s, right? So that's going to be C, right? That's clear to me. But then we have all these other versions of it. So log base 10 of what gives me 2. So if I was to write this out here, I'd say, oh, this is log base 10 of 100, right? This guy right here. So 500 is bigger than that. So I'm going to put D right here, right? This one, log base 10 of 150. Well, I know that 1 is log base 10. Oh, wait. Yeah, log base 10 of 10. I know log base 10 of 10 is 1. So 150 is somewhere between 100 and this one right here, which was 1,000, right? This was log base 10 of 1,000. So I'm just kind of rewriting my number line so that it fits my base 10s, right? So then, oh, so 150 is bigger than that, but way smaller than 1,000. So I'm going to put 150 right here, closer to my 2. And so did I do those all? Oh, no, I didn't do this one. Log base 10 of 50. Well, that's bigger than this, smaller than this. So I'm just going to put him closer to the 1 so that there's A. So these don't have to be exact here. These are not meant to be exact, except for this one, right? He's exactly on 3. But these ones here are not meant to be exact. It's just, you can definitely compare B and D, right? You guys can definitely see why B is smaller than D, right? Beautiful, beautiful. That's fine. Don't worry. Okay. So go ahead and make sure that those make sense. If they didn't, just watch this video again. All right. Have a great day.